So to practice dilation with Geogebra, we just look for Geogebra and I open the first result, and here in the three lines you have different options. Don't select here geometry because those are different resources, so you have to go to calculator, and in calculator there you have geometry again, so that's where you have to go. So you are in geometry, and so here you have a blank canvas, so I think it's better to have the axis. So then here on the clock that you have here on the top right, you click there, and then you have the first option that says show axis, so you click there, you can see the axis, then you tap again on the clock, and then where it says well, here it's in Spanish, but in English it should be visible grid. So if you click there, you have like major and minor grids, so you select that, and now you have the grid. Okay, so then first of all we are going to trace our segment, so you select the segment here on the tools, and you can trace your segment pretty much whatever you want. So I'm going to trace a segment here. Alright, so it's the segment AB, and so to dilate it we need a point, that's called the point of dilation or center of dilation. So you select here point, and to make things easier I'm going to put it here in 0,0, okay, in the origin. So there you go. So since books use or refer to this point as C, I'm going to go to move to the arrow here to select my point, and then you have these options. So if you click here on the 3 points, properties, and here you can change the name of the point. So I'm going to change, instead of C I'm going to use B, so it matches the name of the point that is used on books. Okay, and then we need a scaling factor, that is how bigger or how smaller you want the segment to be. So let's say that you want the segment to be twice as big. Alright, so then the factor is going to be 2. And to do that, I'm going to, well, here just for you to keep that in mind, I can write here, I can use here text, and I am going to write here that I am using the scaling factor. The scaling factor is 2. So remember, that means that the dilation of this segment is going to be a segment that is twice as big. So to do that, I'm going to go back to the basic tools, and here you have a line, you have the line tool. So you select that, and that asks you to trace a line from the points. So I'm going to select the first point, that is my point P, and the second point, point A, so that I have a line. Now I'm going to trace another line, so I'm going to select point P again, and now point B. Alright, now here we have these lines, then what you can do with these lines is you can trace as many lines as you want inside or between these two lines. So if you notice, if I trace a line that is getting closer to the P, it's a line that is going to be smaller than the original line, so there the dilation is making the segment to be smaller, so the scaling factor is less than 1. And but in this case the scaling factor that I chose is 2, So the segment is going to be on the other side, okay? Because every segment that I trace in this area is going to be bigger than AB. So to know where the scaling factor 2 is, I need to check the distance from the point P to the 2 points or the 2 extremes of the segment A and B. So if you notice, from P to A, we have 2 to the right and 3 up. So if I want this segment to be twice as big, I'm going to move twice the distance. So instead of moving 2, I am going to move to 4. So I'm going to choose here the segment. So I'm going to move to 4, and instead of moving to 3, I need to move 6. So now my point A prime is going to go in 4,6. Now for point B is 3,2. So then again, if I want this to be twice as big, I need to move twice the distance. So instead of 3, I'm going to move to 6, and instead of 3, I'm going to move to instead of 2, I'm going to move to 4. So it's going to be right here. Okay, so I'm not going to change the name now, but we know that C corresponds to A and D corresponds to B. And if you notice, these two segments are parallel, and segment CD is twice as big as AB. You can even notice here that AB is the size of one of the large squares, and segment CD is 2 of the large squares, so it's twice as big. And that's how you dilate a segment with a point of dilation and your scaling factor.